Welcome back, guys. So it's been a while. I was expecting to stream last week, but then then my internet is still too low. Let me see if I can get better. Maybe it's just my Wi-Fi connection, so I'll try to open my gate. Let's see if it's better. Yeah. But my connections are getting dropped a lot, so I'm not sure how it's gonna go. Let's see. Looks like it's better now. A little better. Hi. Good. What's up? So I'm just trying to check if my internet connection is still good enough. Yeah, last week I wanted to stream after that, but I did only stream once. Other than that, I didn't get enough time. I was completely out the whole week. So yeah, let's see if we can continue streaming this week. So today I wanted to go through the actual is my screen visible? Looks like it's not. Have to change it. Okay, do that. Okay. Okay. That should be better. Okay, I guess my screen is visible now. I guess I better turn off my camera. At least that way my overall stream would be better. Is it better now? I turned off my camera, so right now it's just my. Mm, yeah, so my internet connection here is not good. So I guess without my video, it's a lot better. So overall, last week we did manage to get a little bit of extra. I remember getting this done. Yeah, we added this extra new thing, this entire looking over all those extents and trying to parse it again. I think this is the new one we added. Yes, this is the new block, which just simply goes through it and uh, gets it. Takes the inode. Within that, it goes takes the I block, parse the entire I block, and that's it. Just return it. And we need to do that for every extent, at least for 128 in our case. And it's just going to continue if there's nothing left. And other than that, there's nothing else. So what I wanted to do this week is just to compile it and just fix the initial errors. Once if we get the initial thing working, then we can actually implement the recursive version. So currently only does for a single node. You need to do it for every node. So it's like we are doing it for the root. We need to recursively do it for the etc and anything that's coming after it, so that we'll know it's actually going through the entire file, because the f open is taking a full path. So the recursion will be somewhere here. That should be good. What we have to do is start compiling it and see what are the errors, and then maybe fix them, and then we can think about the rest. Also, I need to actually commit it. So I haven't been committing anything for a long time. Some random version. Let's just push that in. Okay, now let's run it. We don't have run. Let's build. Compiled without any errors. That's not good. Probably we did not link something. It feels weird that it compiled in just one run. Let's see. So it did compile, so let's check. It's like that. Okay, the actual output does not matter. All we have to check is if we are able to go through the nodes recursively. So we take the first inode, we get the inode block, we get the physical block after that, and the physical block is 8481. Okay, fine. And we are returning the entire result. And the count is 1. So what the fuck did I add? Extras. Okay, last week I just managed to make things dynamic, because previously when we compiled this example, most of the code was just static. Right now things are a bit dynamic, because that's the only difference. So I don't know if my stream is still up. Let me check. Okay, the stream is still alive, so that's good because I'm getting like packets getting dropped around 40% of my packets are getting dropped, so I don't know how good my stream is coming. Uh, I guess I'll just continue. Hopefully, nothing is going bad. So overall, only thing that we did last week is just to make sure things are dynamic. Right now, we are just directly passing inode and everything is dynamic here. We are also passing the extents dynamically because here we go through every extent. I don't know if this part actually works. So maybe it does work. Okay. Okay, I guess I was hoping I would get lots of errors and I can fix them, but looks like there's no errors. I don't know why, but so if that's the case, then the next thing we need to do is that we need to write some sort of string parsing so that um, we know all the paths. So we start from here, we find all the internal strings and we have to use that to we have to check if the current parent actually has that node or not, something like that. So how do we do that? Wait, I didn't even implement this, then how did it work? That's the thing, I haven't even implemented it. Something is clearly wrong. Let's check that. No, I have no clue. It should be roots or roots. It's not that. Maybe it's not even called. So we're here, we go into explore tree recursive. Here we find the root node. We're able to see this output too. We're able to see this output. Only thing that's missing is that it's pause. What is it that I'm missing? I'm not sure. Should be yeah. Also, so I guess my internet is not really good, so I'm just going to be recording it too, just in case if my internet is not good, I can just upload it after. So that's the, I can just upload it later. So I'm also recording it right now. So what I'm trying to do here is just RF open implementation is little bit of, initially was little bit of hard coded stuff. Right now we changed it into um, dynamic execution, but for some reason it just works instantly, which is a bad sign because that means the new code that I added never reached probably. So I need to find a way to actually see what's going on here. Let's explore the recursive. I have to unlearn. I have the actual result. That means I have to call this somewhere. We're passing the results. So yes, I haven't even called that function. That's the issue. Okay, let me call that. It's going to be a recursive directory passing. So initially we have the root node. We get the result of the root node, and we are going to pass. Since we have the actual results, which is just the extends passing of the initial root node, now we have to go into the physical blocks of every extent that we parse, and that physical block actually has the output of the root node, that is the root node's entire value. Now we have to either pass the root node's value as a directory or as a file. That's why we added those entire functions. But I just did not call it here. That's why I didn't get any new errors probably. So here I just have to pass results. And then I also need a extend directory nodes results array. So let's call that. How is it going to be? It's like we need extend directory node. And it's going to be directory entries. And let's say Kernel. It's just going to be size of extends directory node star, because it's just a pointer, so we could just give uint64. That should also work, because we are only going to store pointers, but just to be sure, let's see. I think size of a pointer is uint64, so it's fine. Whatever. Let's do this. And we're gonna pass up to, let's say, 24 entries. So we're gonna pass up to 24 entries. And so it's going to be directory entries. Also, we have to initialize the directory entry too, because here we are directly using that variable. So we do have to initialize it. So let's say for int I equal to 0, I less than 24, I plus plus, and we can just initialize those entries. So it's going to be directory entries of I equal to, it's going to be kmalloc size of directory entry node. And we need to cast it as extend directory entry start. Now we have initialized an array of pointers, and we have also initialized those pointers with actual memory. So That should be good. Yes. Now we can move forward to the next value, which is the directory count. What does that mean? Directory count is, I guess, it's just 0 because we start from 0. Yeah. The count is just 0. And what do we get out of it? We get the count of directories. So it's going to be uint 6014 counts. And let's just print that. Total directory costs. And let's just use Yell. And it's going to be this. Okay. And then I guess now it's time to run it and see what happens. Okay, now we have lots of errors and it's fine. Just have to put extends directory node point. Run it. Looks like we did reach this now. So we are here and we were able to print the entire output. So as I said, we actually found the root nodes inode and we found the physical entry and so the physical node. So we have those values. Now now we have this raw data. We need to pass that into a directory entry. That's why we have this new function and it's just taking that raw bytes. But looks like it did not do anything. So let's see if it returned anything. Parse directory entry return. Let's see if it has written something or we just have to debug that entire function. Well, it's possible it does. I don't know. Let's see. So we are pretty sure that we have the raw data because this is the raw data, and as we can see, we have all the file names. So, but we need to parse this raw bytes into an actual every entry, and we can do the recursive check so that if it has opt, we'll also go and consider that opt as a separate node, and we get the block result for it. That is what we need to do. So let's build it again. So this did return something. I don't know if it's valid or not. We did not get this output, so for sure we are stuck somewhere in this. Maybe let's bring this and let's run it. Because at the moment we ran that, the actual parsing worked. So there's something wrong with our function, our loop. Okay, so that's fine. You can figure it out. So we go through all our directories. First of all, I'll be returning in. We don't have anything here, and what the fuck do they expect? Ah, shit. We don't have anything here, so we need to first of all write the parsing. So what do we have to do here? We need to parse this entire raw bytes into probably we need to parse it as this. And I remember saying something like we need to first of all cast the entire bytes with this entire struct, but we don't know the value of this. So we cast it as this, and we get the length, and then we add it here and we get the file name. That's how we are supposed to do it. Okay, so let's see. Let's say event start equal to 0. So we start from the 0th byte. We cast the entire bytes. I built my first project. That's really good. Terminal text editor. Okay. Did you manage to finish the? Was that there's some algorithm to go backward and go forward, the undo and redo part? I know that the first time I learned about the data structures, I had this example about postfix and prefix. It's our simple depth first search and breadth first search, I guess. And one of the application of that uh, algorithm is text editor, because we will be able to go back and forward by maintaining a list of mm, things, something like that. I remember something like that. I'm not sure, but it's a really good project, because you have actually managed to do both GUI, because you have an empty buffer and you are able to manage the entire UI there. Yeah. Yes, that sounds good. So in our case, now we have the entire output of the root node, which is this. Now we have to cast this raw bytes into this structure, but there's one field that is dynamic, so we need to make sure we get past that field properly by reading this field. Okay, so first of all, let's just cast it once. So it's going to be mhm, it's going to be an extend directory node. Directory node pointer current node equal to, let's also say event 64 parse node equal to 0. So while parse nodes is less than 10, we keep doing this. We can parse up to 10 nodes. Let's just keep that as it is. Yeah, it's the redo and undo and redo function is the one thing that the one that I learned initially, that it makes an actual application for learning data structures. Because initially back in university, when we start to learn data structures and algorithms, it just feels mechanic. There's no real applications to it. But then once we learn the applications for it, we'll know that yeah, it makes sense. These things can be used here, and it actually brings value. Yeah. Also, like I that myself, but I believe is it like a 2D matrix? The entire GUI is just a matrix, right? And you have to make sure you are going through rows and columns and you are editing things. I don't know, but I guess that's how it is. At least that's what, if I were to write it, I'll be starting with that approach. Just big rows and columns. Okay, so let's just cache this empty data. So we can do like this. It's going to be exact no, and it's going to be raw bytes plus start. Let's put current tag and let's check current mode. Let's remove this because we don't know if the actual input of this field. So let's remove that and current nodes length. We want this length. So it's going to be, I guess, I don't know what's the length of it. I guess it's not going to be more than 256. So let's just use uint 8. And it's going to be parameter of what? Name length. Now we can, so parent plus equal to, we need to get past the size of uh, extend directory node. So we will be getting past these 3 bytes, and then we also have to get past this current node length. So this is like one entry, this whole thing. So this full size of an extend directory node is the size plus length of the file, length of the string, whatever it is, this file name, length of the file name. Okay, so our parsing should progress properly. We start from the 0th byte, we cast it as an extend directory node, we get the length of that node, and we are able to get past it, and then we can now just put UR printf. We can write a for loop here, and I equals 0. I less than current node length, I plus plus, and we can print it as UR printf, and it's a character. So we start from raw bytes. No, we start from raw bytes plus current plus size of extend directory node plus I. So this is the current string. So let's just picture it. Let's write it like this. So it's like we have the field 1, field 2, field 3 and field 4. And the final field is the actual file name. So for every iteration, we have to move past size plus length of file name. So it's like that's why when I want to actually print it to, I need to start from the which is the base pointer plus the current, which is whichever current is that, and the size of the directory node, which is to get past all those fields. And then the actual file name here, we just print all those characters. And then we can just move the current pointer to move past this entire field. And we can again do the same thing for the next node. Hopefully this will work. Let me just run it. I don't know if it works. Let's see. We put direct and here we can just put slash and slash. If we do that, let's see. We have a lot of nothings. Okay, let's just increment parse nodes plus equal to 1. We only pass 10 nodes. Looks like we did not pass it through actually. Okay. Yes, 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 that makes sense. Each row being that, yeah, that's how I would have also pictured it, but I have never tried it myself. I have, yeah, probably I might have to write something for my kernel sometime in future. Yeah, so I'll try it that time. Okay, so directory entry did not work, probably because of my current node length. So let's print our current node length. Also, we need to set it as event 8. Maybe it's my format specifier that's gonna fuck me up. Let's see. Current node length is 118. That's not possible. First of all, we have current node length as 1. So the directory entry is just nothing. What do you mean by what's dynamic array? Dynamic array is just probably just a big chunk of memory that can keep growing. Maybe we should try using arena locators so that we don't have to worry about moving the entire array. You can just keep increasing the size of that entire buffer. I don't know if that's possible, but I've seen that if you want to do lots of allocations and if you're constantly changing the buffer size, it's better to just allocate a big chunk of memory inside your arena, and you can increase that buffer size and decrease it whenever you want without having to copy the entire thing. Because if you just have a normal dynamic array, you'll also have to worry about copying things when things are full, which is costly. And you don't have to do that if you allocate it inside your arena, because you can just increment the whole thing. And coming back to my fucking problem, I believe maybe I have to move past some empty data here. It's possible. Let's open the browser and check the actual entry. Maybe we need to move past some magic bytes or something. Okay, this is the directory. That's the directory. Okay, it's the directory entries. Directory entries are supposed to just so it should have just worked. Why is it not working? This is my raw bytes of that root I know. And the entire block should be of directory entries. Yeah, the entire thing should be of just directory entries. So if it's just directory entries, that's why I have my directory node, and it's just of just fold fields as per this. Now as per this. So I'm casting from the zeroth, so it's the raw bytes. So I'm starting from the zeroth byte and I'm casting it as extend directory node, which is raw bytes plus currents, and I'm taking the node length out of it. And what is my node length? It's uint 8. And I'm printing it, and the first time it says 1, and the second time it is 118. And after every iteration, I'm incrementing it of size plus current node length. So it should be fine. Ah, yes, I know. I guess it's just my stream. My stream is just, my internet is just not good. I'll have to switch to some other location. That's why I try to turn off my video to see if it helps, but currently I guess it's not helping. Looks like it's still buffering a lot. Hopefully it gets better. I don't know if it does. Whatever. But let's see. Can you guys hear me now? I'm just trying to see if I can make my internet better. And for some reason my fucking internet is slow. I guess this is why it's not working. Still 24 bytes. Or what? Maybe something wrong with my OBS. I don't know. Okay, I guess I'll try to do something next. But now I just have to continue with this setup. I assume it's going to be a pain to watch if my video is constantly buffering. Sorry for that. Hopefully it's going to get better. Okay, is it better now? I just try to turn off some things that are running my other device. Okay, I'm just going to continue because right now, as in OBS, I see the connection is stable. So as I was saying, as we have the raw bytes, we should be able to cast them as extend directory node, which is just a small struct which has these fields. It also has an extra field, which is this. But but we need to dynamically get the value of that field to get past it. And that is what I'm doing here. So I have the raw bytes, I have the start as 0. I'm casting the first byte as extend node. I get the length, I print it, and it says 0 initially. And then I have to increment the current plus size of directory node. Size of directory node, let's say size of directory node should be these fields. I think it's just 16 bytes. 32 bits is 16 bytes, right? Or 8 bytes. It's just two 32 bits. 64 bits. I guess it's 8 bytes. Yeah. So it's just 8 bytes. So let me change this to 8 then. Let's see if that makes any difference. Looks like it did not make any difference. That doesn't help. I guess I'm going to stop here and see what exactly is there inside the um, GDB. So inside the memory, so we know what is exactly there. My idea is simple. I have some raw bytes. I'm going to start from zeroth index. I'm going to cast it as that structure. I'm going to get the length of it. I'm going to increment path rate. But the idea looks simple, but and also the raw bytes looks fine, but the parsing is not working. So let's just copy this. Let's just copy this and let's go into our function. Here we can, let's disassemble parse directory entry, and let's stop here and see what exactly is going on, because I'm not sure. So we need to break here and we need to get into our virtual file system. Fucking, it's my virtual. So the moment I run it, now I'm inside my parse directory. Here, I guess x0 should be the first argument. So let's examine that. X0 looks like this. So if we copy that and we examine 50 of it from this location, this is what we get. How to cast how to cast address as type inside GDB. Okay, so we just use type. Okay, so I want to cache the front top, and it's going to be extend directory mode, but it's not working. Why is it not working? Okay, for some reason my casting is not working, but whatever, I should still be able to figure out a little bit from here. No, wait, I know. Physical block. And, pass this raw block as this struct to parse raw by introductory entry, but my parsing is not working. Let's see. Let's see what the fuck is wrong. Because looks like our raw bytes is fine. Our parsing is also looking almost fine because it's pretty straightforward arithmetic, and our structures is also fine. We also managed to convert it into just this, so that's not, so probably it's not an issue with the actual byte calculation either. Yeah, I know it's a variable because I'm not treating it as entire directory entry. I know that it is a variable length record. So I have considered it as just this. Oh, okay, I need to use record length. And we get past record length. Okay, let's try that. It's going to be current node, just record length. So I don't need that 8 either because it's, the entire thing should be there. Even here.